Okay, writing a repeating decimal as a fraction is similar to writing a not repeating decimal as a fraction. You can tell it's repeating because it'll have a line over the numbers. And this line indicates the repetition. Okay, so this one, it's just over 49, so this would be 5.49, 49, 49, forever and ever and ever. This would be 0.621, 621, 621, 621, and it goes on forever, it never stops. So what we want to do, we're going to count all the digits. Okay, both the repeating and the non-repeating. Doesn't matter. You're just going to count all the digits. And then, whereas before we were putting zeros in the denominator, we're going to do nines now. Okay. And I can show you the algebraic reason why that is if you want to see it. Or you can just accept it on faith and skip the algebra part. Does anybody want to see why it's nines? Yeah? Okay. So here we'll look at point 3, repeating. Okay? If I say x is 0.3 repeating, there's one decimal place. So if I multiply by 10x, that's going to be 3.3 repeating. And if I subtract x from here, that's the same thing as subtracting the 0.3 that's repeating. And I get 19 in the denominator. One decimal place, 19. And then I reduce. Or I can skip all this middle bit, and I can just say 2 decimal places, 2 nines. Easier. This is why, or like I said, or you can accept it on faith and just count the decimal places, and that's how many nines you use. So if you recall, back when we were talking about non-repeating decimals, we said 2 decimal places, 2 zeros, and then we reduced it. Here we're saying 2 decimal places, 2 nines, and then we're going to reduce it. Both 45 and 9, d9, divide by 9. And so this is going to give me 5/11ths. Okay. 621 repeating. So I have 3 decimal places, 3 nines. If I add these together, I get 6 plus 2 is 8 plus 1 is 9, and then I get 999. So these will both divide by 9. So that is going to give me 9 goes into 62. I'm going to cheat. Okay, 69, if I add that together, I get 15, and if I add 111 together, I get 3. So this will divide by 3. And so I get 23 over 37. But I'm still going to count all 3 digits. So I have 549 over 999. Okay, so 3 digits, 3 nines. These will both divide by 9. Okay, this is 7, so it does not divide by 3. Actually, 61 doesn't divide by anything. It's prime. All right, so we're going to list all of the perfect squares up to 20, and then 25, 30, and 40, and stuff like that. So 1 squared is 1, because it's 1 times 1. 2 squared is 4, because it's 2 times 2. 3 squared is 9. 4 squared is 16. Here's where I'm going to, well, we know that 2 squared is 4, so the square root of 4 is 2. 5 squared is 25, so the square root of 25 is 5. Square root of 100 is 10. Square root of 625. And like I said, you just go on this list and you just look down and you go, oh, 625, there it is. Ooh, 25, perfect. Okay, same thing, 196, you look until you find the 196 and you say, okay, that's going to be 14. Okay. If we have a fraction with perfect squares inside of it, this is the same thing as square root of 25 over the square root of 100. Not 100, sorry, I'm looking.
Ours is different.
Is it?
25 over 121.
Okay. Over the square root of 121. So this, you don't have to write this step in though. You can just take the square root of 25 and the square root of 121. Mm-hmm. 5 over 11.
That's the answer?
Yep.
5 over 11.
That's the answer right there. So we'll do that. Well, is yours 36 over 100?
No. 16 over 81.
See? I told you. Ghost. Right? So I can take the square root of 16, which is 4, and the square root of 81 is 9. So, I mean, it looks confusing because it's a fraction inside of a square root. So, I mean, visually you look at that and you're just like, oh my gosh, that's so much, right? It's fractions and it's square roots, and I don't like either of them. But you look at it separately. You look at the 16, you look at the 81. Just as an example, in case it comes up, let's say I had, I'm going to actually scoot that over so I have more room. 50 over 72. Okay, these are not perfect squares. So what I want to do first, I'm going to see if I can reduce this and see if it makes perfect squares. So these are both even, so I'm just going to divide by 2. And so I get 25 and 36. Now I have perfect squares, so then I can take the square roots. So if you see not perfect squares first, see if you can reduce it, and then if it reduces, then it'll be a perfect square, maybe. And I mean, estimation means to not guess, but make an educated guess or an approximation. Okay, so here's how we're going to do this. Do you guys have all these exact same numbers? Okay. So I'm going to look at the square root of 19. I'm going to rewrite them kind of over, down, so we have more room. Okay, square root of 19. Okay, 19 is between, come back here, is between 16 and 25. These are my perfect squares, right? So it's between 16 and 25. Which is it closer to? right? It's closer to 16, so I'm going to say the square root of 19, and then I'm going to make this squiggly equal, and the squiggly equal means approximately, so that means right? So 19 is between 16 and 25, so it's between two perfect squares. It's closer to 16. The square root of 16 is 4, so the square root of 19 is about 4, or approximately 4. Whenever you make these squiggly equals, it means this is not the exact answer. I'm making an estimation.
Is that a legitimate answer?
Yeah. As long as you don't put equals. Because it doesn't equal 4, but it's close to 4. And if you want to check it, where's my square root? There it is. 4.358. See, it's close to 4. All right, we'll do, okay, 38 is between which two perfect squares?
6 and 7.
Well, what are the
36 and 49.
36 and 49, right? Which one's it closer to?
36.
So it's closer to 36, so then the square root of 38 is approximately 6, because the square root of 36 is 6. Okay. Square root of 27.
25, 36.
Which one do you guys think it's closer to? 25, right? Yep, so the square root of 27 is approximately 5. Do you want to do the other two, or do you think you guys have it? Got it, yeah. All right. When you're adding integers and they have the same sign, okay, it's like a matching game. The signs match, yay. So when they're the same sign, you're going to add the numbers and keep the sign the same. Okay. This is never a problem with positives. You guys have that down. Positives are good. 2 plus 5?
7.
7. Okay, negative 3 plus negative 6.
-9.
Yeah, you're going to say 3 plus 6 is 9, and it's negative, so you keep it negative. 6 plus 6 plus 3?
15.
15, right? They're all positive, so my answer is positive. And then negative 5 plus negative 3, so it's 5 plus 3 is 8, plus 9 is 17, so it's all negative, so it's negative. So if you have a hard time with positives and negatives, start thinking about money. Positives are money you have. Negatives are money that you borrowed or that you owe. If I borrow $5 from you, and then I borrow another $3 from you, and then I borrow another $9 from you, I owe you $17, right?
It's easier to think about if it's just -5 minus 3.
Not for some people. It depends. Like, if you have different signs, you're going to subtract the numbers. If they don't match, you subtract. And then you keep the sign of whatever number was bigger, not greater. And I make that distinction because positive numbers are always greater than negative numbers, but 6 is bigger than 2, even though it's a -6. Does that make sense? Okay. So I have a 6 and a 2, one's positive, one's negative, so I'm going to subtract. I get a 4, and then the 6 was negative, so so's the 4. So I borrowed $6 from you, I paid you back $2. I still owe you $4. Okay. 10 and negative 4. This is the same as 10 minus 4, if you want to look at it that way. So that's 6. The 10 is bigger, so my answer is positive. Okay. Here I have 2 the same and 1 different. So I'm going to combine these first, the same ones. Negative 4 and negative 12 gives me negative 16. And then I have a positive 13. And now I am going to subtract because they're not the same. So 16 minus 13 is 3. The 16 is negative, so is my answer. And then negative 15 plus 12. Wow. 3, and it's negative. Really, if it works for you to not convert them, you don't have to convert, except for in one situation where you always have to convert. But what we do is we add the opposite. So we turn subtraction into addition. And we add the opposite. So instead of being negative 4 minus 8, it's the same thing as negative 4 plus negative 8. 9 minus 15 is the same thing as 9 plus negative 15. This is where you absolutely have to change to addition. Minus a negative. Looks like a happy person. Happy is positive. So this becomes negative 3 plus 12. So 2 negatives make a positive. So see, he's happy. So it's positive. Other thing, if you don't like the little happy man, if I connect the dots, doesn't it look like a giant plus sign? So, and then here if I want to convert that, now that I've converted them, I have 2 negatives, so I'm going to add those together and keep the sign. Here I have a negative and a positive, so I'm going to subtract, and the 15 is larger. Negative and positive, so I'm going to subtract, and the 12, which is positive, is larger. That's just addition. And here I have 2 negatives, so I'm going to add them and keep it negative. Doesn't matter what number's bigger, doesn't matter what it's, if they're both negative, it's positive. If they're both positive, it's negative. So 2 positives make a positive, 2 negatives make a positive. 2 positives, by the way, this is division, make a positive, 2 negatives make a positive. 2 negatives make a positive divided by a positive is another positive. Any questions on that? Okay. If you had different signs, they don't match. That means you did not win. And that's negative. So negative times a positive is a negative. A positive times a negative is also a negative. Negative divided by a positive is a negative. And if I have 2 negatives, or sorry, a positive times a negative, that gives me a negative. Divided by negative, oh, hey, look at that. I finally got a positive because I matched. Perimeter. Perimeter is the distance around the outside of an object. Okay, in order to find perimeter, you can either use the following formulas or you can just add up all the sides. It's up to you. So use formulas or add up the sides. Okay, the formula for a rectangle, if this is length and this is width, you have 2 times the length plus 2 times the width. Okay, same for parallelogram. If it's a square, it's 4 times s. And if it's a triangle, you're just going to add up all the sides. There's not really a formula for it. So if this was like x, y, and z, it would be x plus y plus z. Any questions on that? Okay, so we're going to find the perimeters of the following. If we use the formula, well, okay, if we decide not to use the formula, if this is 8 centimeters, how long is this? And this is also, right, same here, this is, yeah.
Let's say on a test, if you were to do this, would you want us to put units?
A perimeter on a circle has a name. Circumference. Okay, and the circumference for circle is either 2 pi r or pi d, where r is the radius and d is the diameter. Okay, that's all right. So radius is halfway across and the diameter is all the way. Right, so if I give you diameter is 12, okay. Hold on a second, let me get pretty. And this one was radius, right? Alright, so this one's 12 inches. What's the radius on this one?
37.
Okay. So if I have diameter, I'm going to use pi d. Okay, and pi is 3.14. Actually, pi is much longer than that. It goes on forever, but we're just going to use 3.14.
If you write the letters back, the numbers backwards, it looks like the word pi.
Yes, if you do your 4 the old-fashioned way. Okay, so I'm going to take, and I'm going to use the diameter, so my circumference is going to be pi d, so that's the same thing as 3.14 times 12. So 3.14 times 12, so 37.68 inches. Okay. If I'm given the radius, then I'm going to use the 2 pi r. So that's going to be 2 times 3.14 times 3. Decimals, and we're not going to do this on the calculator. You line it up like normal multiplication. Get an answer, and then you count all the decimal places to begin with. answer has that many. Okay, so I'm going to do 7.2 times 0.02. Now I'm going to ignore this negative for now, just knowing that my answer, because I'm doing a positive times a negative, my answer needs to be negative, right? Okay. So if I do 2 times 2, that's 4. 7 times 2 is 14. And if I do the zeros, it's not going to add anything. So I have 1, 2, 3 decimal places in my, did you guys see that? 1, 2, 3. So I have to have 1, 2, 3 here. And then I know it's going to be negative. Okay. They follow the same rules as integers. Okay, so if I multiply these two together, negative times a positive, what's my answer going to be? Okay, so this one I'm going to use the calculator. Yeah. Sure. Why is it not working? 5.4 times 1, 2, 3. No, darn it. So it's 0.027 and it's going to be negative. Okay, negative times negative is going to give me positive. Okay. Dividing, if I divide a negative by negative, my answer is going to be positive. So 23.94 divided by 10.5. This will be 2.28. Do you guys have the same two numbers here?
Yeah.
Make one of these positive. Make the first one positive. Now if I divide a positive by negative, my answer is negative. So I'm going to have negative 2.85. So if I'm going to do 2/3 times negative 1/2, okay? First of all, because I'm doing a positive times negative, I know my answer is going to be negative. And then I just multiply straight across the top and straight across the bottom. And that gives me 2/6, which will reduce to 1/3. Or I can cross cancel. Okay. To cross cancel, what I do is I look at these two numbers and these two numbers. 2 and 16, will they divide by the same thing? Yeah, they'll both divide by 2. So if I divide each of these by 2, I get 1 and 8. And 5 and 15, they both divide by 5, so I get 1 and 3. Then I multiply across, I get 1 times 3 is 3, 1 times 8 is 8. And I'd get the same answer if I just multiplied straight across and then reduced. Basically, you can multiply and then reduce, or you can reduce first and then multiply. It's just up to you which you prefer. I've had students in the past that did not like cross-canceling and they found it confusing. If it's confusing, don't do it. Mixed numbers. You cannot multiply mixed numbers, period. Can't be done. You have to convert them first. Okay, so if I want to multiply 2.5 times negative 1 1/3. Actually, let's make that 2/3. Okay, I need to convert these to improper fractions before I can multiply them. Okay, to convert them, I'm going to multiply these, and then I'm going to add that to it. So I do 2 times 2 is 4, plus 1 is 5. So this becomes 5 halves. 3 times 1 is 3, plus 2 is 5. Now the sign doesn't change, right? So 3 times 1 is 3, plus 2 is 5, so it becomes negative 5/3. Then I can multiply it. And what I get is a negative times a positive gives me a negative. (25) and 6 don't reduce, and you don't have to convert it back to a mixed number. You can totally leave it as an improper fraction. Improper fractions are fine, and as a matter of fact, they are preferable. So that's your answer. Reciprocals. If I have a fraction 2/3, the reciprocal is 3 halves. If I have a whole number 4, the reciprocal is 1/4. Likewise, if I have a fraction 1/5, the reciprocal is 5. Reciprocals just flip over. So, okay. To divide fractions, you multiply by the reciprocal. Or, as I like to say it, you copy, and then you dot, and then you flip. Or, I've heard you keep, and then you change, and then you flip. Keep, change, flip, it's KCF, whoops, KCF instead of KFC. You guys heard that? Okay. I like copy, dot, flip. But okay, so if I'm taking 2/3 and I'm going to divide it by 3/5. Okay. And the reason I chose that is because here, if this was multiplication, you'd go, oh, I can cross cancel that. But you cannot cross cancel in division. You can only cross cancel after you've turned it to multiplication. So what I do is I copy, oops, thirds, not fifths. I copy, and then I dot, and then I flip. Or I keep, change, flip. Now I can't cross cancel anything, so I'm just going to multiply. And then I'm done. And then they follow the same rules. If I have a negative or 2 negatives, I'm going to copy, dot, flip, and then I'm going to get positive 4 because negative times negative is positive. Okay. Does anybody want to see another example of this, or are you okay with converting them?
Could you show us an example of this?
Sure. If I have 2 1/3 and I want to divide that by, let's say, negative 1/2. I have a mixed number and a fraction, but I can't divide this. So I'm going to convert that first. So multiply and then add. So this is going to become 6, 7. Sorry, I was adding and then adding. Okay, so 6/7 thirds divided by negative 1/2. And then, of course, I have to do the conversion to multiplication. So I copy, I dot, and I flip. Then I see, can I cross cancel anything? No, I can't. So then I multiply.